So I'm going to start sharing again. So this time I'm going to get into, I don't like my PC. I'm going to go into my class notes and I'm going to go into section 8.3, which we haven't actually talked that much about. So we're going to go into that section. It's a little slow. There we go. All right, and 8.3 is the confidence interval for the one proportion mean. So I didn't do a hypothesis test on this because people really don't, but really you could do a confidence interval for the mean. So you might want to know what is the mean height of a woman, or what is the mean incubation period for the coronavirus, or you might want to know the mean income level of nurses, or you might want to know the mean income level of people who have a college degree. These are all different things you might want to ask. And so you might want to know what these are. So just as before, with all of these confidence intervals are the same way. You're going to state your random variable and parameter in words, and then you're going to state and check assumptions. These assumptions are the same as the one in the hypothesis test. I don't know why that didn't say confidence interval. Which we didn't go over those, but these are the same ones we would do. And again, just as the other one, every single one of these is going to have a random sample. So you're going to have a random sample of size n is taken. And then the only other assumption for this one is that we have to have the variable has to be normally distributed. And that's your other assumption. And that goes back to the central limit theorem in a way, is that we want that random variable to normally distributed. If it's not, if you got a big sample, it's okay because the t-test is valid even for large samples. So we'll go through that. And then we'll go through our calculations and then our statistical interpretation and real world ones, just as before. Okay. So we're going to go ahead and do an example of this. So this time I would like to do a major car manufacturer wants to test a new engine to determine whether it meets new air pollution standards. 10 engines are manufactured for testing purposes, and the emission level of each are determined. The data in parts per million are listed below. So these were for 10 cars. And what we'd like to do is find the mean emission level of the new engine using a 95% confidence interval. So I'm going to ask you again my same question I asked last time. Is this a hypothesis test or confidence interval?
Let's just find the confidence interval.
Right. So
it would be a confidence interval.
Yeah, so that wording there tells me it's a confidence interval. Is there any other word that tells me it's a confidence interval?
I don't see anything about the estimate part though. Oh,
it's not,
find
but
the mean.
Find is actually. So find means the same as estimate. So look for those kind of words. And I do this because there actually is going to be a test. The in-class, not the in-class, but the short answer portion of the test that you're going to have is going to have you do this, where it's going to ask you just which analysis would you do. I'm not asking you to find anything about them. I just want to know, is this a confidence interval? Is it a hypothesis test? What are you going to be doing on these? And I get people who get this wrong, even though the word confidence is sitting right there. So I want you to think critically and think about reading these carefully for those kind of words. Confidence is an important one. Find is an important one. Estimate's an important one. Okay. All right, so we now know we're doing a confidence interval. Are we doing a confidence interval for the mean or the proportion?
The mean.
Yeah, how do you know?
It says find the mean.
Yeah, because it says find the mean. So the word mean, again, is just usually in there also. And so these shouldn't be difficult, but they should be going to do this.
It's funny that Jacob just said that because I was just listening in the news about how the Trump administration had changed the emission levels to whatever it was. But that's besides the point.
That's beside the point. And it's beside the point that people do cheat on these. We all know about the issue with Volkswagen, where they actually set their computers to
Oh
what
yeah, I heard about
the
that.
level was during testing. So that every car would pass the emission level testing, but they
And then
would,
they'd be out and they would have more, yeah.
right, yeah.
I remember that.
And the company lost a lot of money on that one, by the way. So you don't want to do that. So hopefully people aren't doing this. I like to teach this in the point of view that I need to do this kind of testing stuff. And this is what we do. I can't help what happens out there in the world with people being unethical. Okay, so we're going to go with the idea that this is what's supposed to happen. I'm not going to deal with the business ethics of it. This is not an ethics course, unfortunately. Okay, so let's talk about how we do this. So the very first step of every hypothesis, of every confidence interval, and hypothesis step for that matter, is to state your variable and proportion and parameter. All right, so I just can't seem to type and spell. So what are we actually measuring in this case?
The emission level,
Okay.
new engine.
Of the new engine, yes. It's not just any engine. I don't care what the old engines are doing. I'm looking for the emission level of the new engines. So I do want to actually state it that way. So make sure I put that information in. So I like to tell people, be wordy on these descriptions, not as minimalist as you can be. Be as wordy as you can be, because it's better to give more detail than less. And then what parameter are we dealing with? You've already answered this, but let's see if we can answer it again.
Confidence interval.
So parameters are things like proportions or means.
Oh, the mean.
Mean. So and again, you can just, that is the mean emission levels of the new engine. So you can actually just go copy and paste it. If you want to use the symbol we use here is the mean, mu. So you can go get that Greek letter if you want to, or you can not worry about it. Okay, I'm not as big into the symbols as I used to be. All right, so there's those two things. We're done. What's the second step of every confidence interval? So I went to the top. What's the second step?
State and check.
Yes, state and check the assumptions. So the very first thing is to state it. And so what is the first assumption always that we're doing in every confidence interval we've been dealing with?
That a random sample size was taken.
Okay, so random sample of what? What did we measure again? We measured emission levels, right? And how many did we measure? So go back and read the problem and see how many did we measure?
10.
10.
10.
So 10 emission levels of the new engine was taken. If you do was or is, I don't care, as long as it's a verb of some kind. Okay. All right, so that's the stating part, and then we're going to check it. So was this a random sample?
It doesn't say.
It doesn't say, but it says something very important. It says the 10 engines were manufactured for testing purposes. So they didn't have just 10, they didn't have like thousands that they made and then randomly picked 10. They actually just made 10 for this purpose. So it's not a random sample in any sense of the word because they only made 10 engines for this purpose. That's certainly not random. But in reality, if you're trying to develop a new engine, you wouldn't manufacture thousands of them and only pick a few, because that would be a waste of resources. So you probably would do it this way, but it's not a random sample. The best we can say is that the engines were manufactured for testing purposes. So it was not random. Now that may not be bad in this case. Hopefully that's not. But that's the best we can do, okay? All right, now what's the second assumption?
It's normally distributed.
Yeah. So we would say the population of emission levels of the new engine. Notice I keep just writing that over and over and over again. I just keep copying and pasting that same thing. And so once I state my random variable up here, I can copy it and then just keep pasting it everywhere I am to what I'm doing. So the population of the emission levels of, and I'm going to stick the word of all the new engines is normally distributed. And then how do we test if it's normally distributed? How do we find out if that's true?
Make it a density plot.
Yeah, so I first need my data. So I happen to have the engines, the thing to read into R right here. So I'm gonna go ahead and copy that and paste it into my RStudio. And then I can come up with my density plot. So unfortunately, we are out of time. We only have 1 minute left of class. So I think we'll do this next time. So we'll finish this one up next time and then move on to 2 sample materials next time, okay? So we're gonna go through and we're kind of stop here at this point. We'll finish this problem next time, show you how to finish this out. You're almost there. We just haven't done the actual test yet. And then we'll do the test and show you how that all works, okay? All right, everybody good? So one last thing I just want to mention, and I'm going to stop sharing and I'm going to stop recording.